Okay, here we are in lecture 5 of one single chapter, and we're not done. We've not even looked at solutions molarity and solution stoichiometry. So this is kind of a beefy chapter. All right, we're going to continue identifying oxidizing and reducing agents and the species that are being oxidized and reduced. So here we have a new reaction, mercury oxide. And we know that oxygen is always going to be -2 in its compounds unless it's a peroxide, which means that mercury has to be +2. Over here, mercury by itself has to be 0, and oxygen by itself also has to be 0. So we have mercury going from +2 to 0. That means it gained electrons. It must be the species that's reduced. So mercury is reduced, and oxygen going from -2 to 0 loses electrons. So that's oxidation. And you should also be able to write the half reactions where mercury here +2 gains the 2 electrons and forms mercury 0 or solid. Okay? So if the electrons are on the left side of the reaction, it is a reduction. If the electrons are on the right side, obviously they're being produced. Loss of electrons is oxidation. So here if we took 2O - 2 and we formed an O to 0, we would have 4 electrons that are being produced total here, right? If we wanted to balance that entirely. Okay, looking at another reaction, we can identify each oxidation number. If you remember what ClO3 is, chlorate has a -1 overall charge. That means the potassium is +1, or actually potassium is in group 1. It is going to be +1 unless it's by itself. So nothing changes here. The oxygen in perchlorate is going to be -2, and the oxygen in O2 is going to be 0. So we can identify one of them here. So again, that is the oxidation, right? Each oxygen here loses 2 electrons. So that must mean, by all means, that chlorine here is being reduced. So but we have to have the oxidation number for full credit. It's easy if it's chloride, it's going to be -1. But here you have to add up all of the oxidation states and charges here, right? So we have 3 times -2, which is -6, and we have a +1 here for the potassium. That means that chlorine is going to have to be +5. So chlorine undergoes reduction. So chlorine, in order to go from +5 to +1, has to gain, +5 to -6, has to gain 6 electrons. So, but for now we are just assigning oxidation numbers, and then are identifying what's oxidized, what's being reduced. Copper is already here, has a little 0 there, so we know that's 0. I'm going to write it above anyway. Here, copper is combined with nitrate. If nitrate is -1, it has to be +2. So here's your oxidation. Okay, so copper is being oxidized. It in itself must be the reducing agent, and what it reduces is the silver. And we know that because it has to, right? The nitrate doesn't change, so nitrogen and oxygen are the same oxidation number. Here silver is +1, and here silver is 0, so that is the reduction. Silver is reduced. It is the oxidizing agent. It works hand in hand. Similar reaction here. Sodium 0 going to sodium +1. That's oxidation. Those electrons that are given off go to the hydrogen. The hydrogen here is +1, and the oxygen is -2. And here in the product for hydroxide, the hydrogen is still +1, and this oxygen is still -2. See how this adds up? +1, -2, and -1. Okay, so that means that this hydrogen here must be the species that's reduced, and that's true here. It's like hydrogen plus going to hydrogen zero. So that, and I'm going to draw it in kind of like that, is the reduction. Okay. All right, so how do I know? Does it always work? All right, so okay, so look at the copper silver. Why does it flow this way? How do I know whether it goes this way or that way, right? Okay, and that's because copper is higher in the activity series here, right? If you find copper, um, it's down here. That means copper is going to prefer to be oxidized over everything that's below. And so silver happens to be below. But if you had copper, for example, and lead nitrate, it would not work. Okay? So if you had copper and anything above, right? Like PbCl, well, that's not soluble. Let's make PbNO3, right? So copper will not reduce lead because lead is above. Okay, lead is more reactive than copper. The other way around, yes. Okay, and so lithium here is the most active. And see how these are listed as oxidations here. Lithium kicking out an electron, right? All of these here are electrons that are ejected, means these are oxidations. And the higher they are, the more they prefer to be oxidized. Lithium is highly reactive. It prefers to be oxidized. It will reduce any of these other metals, right? It's going to reduce even potassium, as reactive as it is, it's going to reduce potassium ions back to potassium, okay? Or anything lower. Let's take zinc, for example, here, right? So we're going to have lithium is going to react with zinc chloride to form lithium chloride and zinc solid. That's going to happen because lithium prefers to be Li plus. But if you had zinc and you reacted it with lithium chloride, nothing would happen here. No reaction, because lithium is higher in the activity series. Lithium is already oxidized. If you go back to this activity series, just thinking about some of the metals that you're familiar with, iron here is kind of in the middle. You know it corrodes fairly easily, so you do know that iron plus, and we don't use that in pipes and for water, for example. And so we use copper pipes. And then if you want something really inert, gold and silver, those are your precious metals here, right? So we have gold rings and silverware, you know, and silver jewelry. So those are the things that don't oxidize easily and are used in pipes and whatnot. And we would not use any of these reactive metals, calcium or iron, you know, iron nails. If anything, we use galvanized nails, right? And galvanized nails are they're covered in zinc. Okay. Looking at a couple more reactions. This is a combustion reaction. And I told you that combustion reactions are redox reactions. Let's go through and assign oxidation numbers. Right? Oxygen by itself is always going to be 0. Hydrogen in a compound is going to be +1. Oxygen here in carbon dioxide is going to be -2, and oxygen in water is going to be -2. Hydrogen in water is going to be +1. So we can see here that oxygen, and then let's do carbon first, right? So if carbon here, if hydrogen is +1, then this has to be -4. Okay. And so and carbon here in carbon dioxide is +4, right? So 2 times -2 is -4. That means the carbon here has to be +4. That's 8 electrons. See, and this is, and I gotta remind you now that this is really not a charge. It's an oxidation number. It's a hypothetical charge. It just helps us identify what's being oxidized and reduced, right? And so that's exactly what's happening here. We have oxidation, and I should just write ox. And where's the reduction taking place? Well, that's from oxygen. See, here's the oxygen goes from 0 to -2, and from 0 to -2 in both of the products here. So it is oxygen that's being reduced, right? So oxygen is the oxidizing agent, right? Which makes sense. It's oxidizing things. Oxygen oxidizing things, right? So oxygen 0 in its elemental state is, as it adds a cross compound, it is being reduced, and what it does, it oxidizes carbon. So this oxygen picks up the electrons from the carbon, and carbon is oxidized to +4. Okay. Here's another oxidation. It's a corrosion oxidation, and it's not oxidizing carbon, but it can iron. It's a very similar process here. So we have iron 0 going to iron +3. So that's oxidation. I'm just going to write ox, and this is going from 0. Oh, look, I have a different font here. I should probably change that. Here we have oxygen going from 0 to -2, so that's again is the reduction. All right, so if you have oxygen on as a reactant going to some sort of oxygenated compound, whether it's iron 3 oxide or water, it's going to be the species that's reduced. Okay, let's do the half reaction method. So this is where we focus on the electrons that are being used and that are transferring. It can be quite useful, right? You can separate both reactions. First, we're going to go copper is 0, silver is +1, copper is +2, and silver is 0. So that's the first thing that we do. We've seen this reaction already, and then we split things into half reactions. So here we have copper that is going to copper +2 and 2 electrons. That's the oxidation half reaction. And the reduction half reaction is silver +1 electron goes to silver 0. See, silver is lower than copper in their activities here, so this reaction will go, right? And so now what we do is we balance the half reactions, meaning we balance the electrons here, right? So we have 2 electrons that are being released, but only 1 that's being mopped up. So we actually multiply this by 2. So we need 2 silver ions for this reaction. And 2 electrons going to 2 silver. So now we've balanced the electrons. They cancel, kind of like the spectator ions do, and have run out of space here. But what happens here is we have copper and 2 silver ions going to copper +2 and 2 silver metals or solids. So that is the balanced reaction that focuses on the redox chemistry and leaves out even the nitrate and the electrons, right? So here electrons are flowing from copper to silver, right? So we separated the reactions. We had the oxidation, the reduction, balanced the electrons, and then pulled it together. Okay. Now, you could balance the equation before doing it. This will actually help you, right? Because we have 2 nitrates here, so you do know you need 2 silvers, and that is confirmed when you balance by this method. Let's do another one by the half method here, right? So here we have cobalt and oxygen. And here oxygen is -2. That means we have 3 times -2. Cobalt has to be +6. So we have cobalt that is going to cobalt +6 and 6 electrons. And so this is the oxidation. And the reduction is, of course, O2 and 4 electrons going to, let's say O, because we got to balance that, 2 oxygens going to 2O minus 2. Okay, so now we balance the electrons here. We have to multiply this by 2, and that would make it 12, and this by 3, and that will make it 12. So we are going to balance the electrons here, right? So what we get is we get 2 cobalts going to 2 cobalt plus 6 and 12 electrons. And the reduction, I should write it down, that's the reduction, half reaction. We have 3O2 and 12 electrons going to 6O minus 2. Okay, so these electrons actually cancel, and then when I bring this back up, and if you balance this reaction, for example, you would have a 3 there, and a 2. Well, wait a minute. We would have a 2 and a 2 and a 3 here, right? So 3 times 2 is 6, and 2 times 3 is 6. So yeah, right. So if we balance that, that would be confirmed, right? So we're balancing based on the number of electrons. Let's do one more, and then take a break and look at solutions. This is the last one, I promise. Lead is 0. Water, there's nothing special here, +1 and -2. The hydroxide is -2, so lead's got to be +2. Now we know what our oxidation is, and here hydrogen is 0. So the oxidation is lead solid going to lead +2 and 2 electrons. That's oxidation. The reduction has to be the hydrogen, right? So you can write that, you're going to have to write that as H+. So we have H+ and 1 electron going to H2. Okay, I guess we're going to need 2 H pluses and 2 electrons going to H2. So this is actually balanced here, right? The 2 electrons and 2 electrons. And when you bring all this back down, the electrons fall out, and you have Pb and 2H plus going to Pb plus 2 and H2, and that is balanced. Okay, when I come back, we're going to talk about solutions.